Our session today will look at hypothesis testing. So hypothesis testing is actually the cornerstone of inferential statistics. It involves us making statements about the population parameters, like the mean, the proportion, then using a sample from the population to conclude whether that statement is true. So for this chapter, we are going to look at how to test a given problem, how to test for one size of the sample, large sizes of sample, and how to apply the principles we had in the previous classes. So just a reminder of our song. We looked at important levels of significance. The common ones we said we have what? 99, then followed by 98,
5,
followed by
98,
95,
95,
then 9.
68, 90,
And the Z for each of these ones. The first one was what?
2.58,
2.58, correct. The next one is
2.33,
okay. Then next one is what?
1.96,
Then
and 1.645.
1.645. So these are the important Z figure that you need to have at your fingertips. Okay. So in this vein, we looked at the sample size formula that we calculate. That if I find the sample size, we looked at two formulas. What formulas did we look at?
The one which has Z squared and some standard squared over the expected.
Okay, so we looked at the sample size. N is equal to Z squared, S squared, and what? Error squared.
Error squared.
We also looked at a proportion, which was given by Z squared, PQ over what? Error squared. Then confidence interval is simply a range within which the true mean will lie. It is coupled by the lower bound and the upper bound. Okay, so if you're told that if it takes me 10 minutes to go to work plus minus 2 minutes, so the earliest time I'll be there will be 8 minutes, which is 10 minus 2, and the latest time is 12 minutes, which is 12 plus 2. So this is got the lower bound, and this is got the upper bound. To find this, it is simply the mean plus minus error term. So to find the mean, we simply add the lower bound, that's the upper bound divided by 2. So in this case, we go back to the mean. Our mean was 10. How do we get this 10? We add 8 plus 12 is 20 divided by 2, we get the 10. So we also looked at the Z values that we need to know. The formula for confidence interval is simply given by mean plus minus Z standard deviation over square root of n. So if we're given a mean of 10 and you're given a sample size n, which is maybe 36, and you're given your standard deviation as 12, and you're given your Z or your alpha as 0.05. So how do we find the confidence interval? So here its mean is 10 plus minus Z, which is coming from 95%, 1.96. And standard deviation is 12 over square root of n. N is what? 36. Square root of 36 is what? 6. 6 into 12 is 2. So 2 multiplied by the 1.96. That is called our margin of error. So when we multiply this by the 2, how do we get? 3.92. So what is our
3.92.
lower bound? Subtract 10 minus 3.92 to 6 point what? 6 point
10 minus 3.9, 6.08.
08. Then when you add that, you get 13.92. It's the upper bound. All right.
Yes.
So this is when you're dealing with a mean. If you're dealing with a proportion, our confidence interval is simply equal to the proportion of P plus minus Z PQ over capital N. So suppose you are told that 30 out of 50 like watch the MBC. So the big population is 50. Out of the 50, 30 love ZMBC. So to find proportion, it is simply the small n over the big N. So 30 divided by 50 is equal to 60%. So meaning what becomes the Q if P is 60%? The Q should be what? What a percent? It's a brain. Then we're given our level of significance as 98% or 2%. So using the formula, how do you find the confidence interval? Confidence interval is equal to proportion. What is our P? 0. What? 6.
0.6.
Plus minus, what is our Z? 2% is the same as what? 2.33.
2.33.
And our P there is what? 0.6. And our Q is 0. What? 4.
4.
And our capital N is what? 50. Right. And you find your confidence interval in the appropriate manner. Here's just an issue of calculating. Okay. 0.33. What is 0.6 times 0.4 divided by 50? Square root.
0.6 times 0.4 divided by 50.
What are you getting?
Just yeah, man. Let me just try again. 24.
So 0.6 times 0.4 divided by 50. Then square root of the answer.
Square root, but
What are you getting? I don't have a calculator. So 0.06 somewhere there. So we multiply that one times 2.33. We get 0.16. Okay, these are proportions. If you want, you can convert them to decimals or percentages. So 60%, plus or minus 16%. What do we have?
60% plus the other one is
16%.
okay.
60 minus 16. And then we have 44% to 76%. All together. So this is how we find the
The inter
confidence interval. Are you stuck somewhere? Are you following?
I'm following.
All right. Yeah. Okay. So now hypothesis testing, hinging upon what we have just learned now. So
Okay.
hypothesis testing is simply testing whether there is a significant difference between two means. So hypothesis testing, basically, in applied perspective, you want to test whether there's a difference in the yield. Normally, if you do farming, okay, the standard yield that you have, the mean is maybe 100 tons. Maybe you will not get 100 tons here. So I thought that suppose you um suppose you had plowed 36 farms with standard deviation of 12 tons, and you found that the average yield that you got from there was 110 tons with a confidence level 90%. The statistical difference between the 100 and 110 was the yield effective. So you need to follow 4 steps. Number one, you set the hypothesis. All right?
Yes.
Hypothesis. That is our mu. Second, you set a level of significance. At 90%, that is your level of significance. Level of significance is 10%.
10%.
Where our Z here is what? 1.645. Then you make the decision rule. Decision rule is to reject HO if we get the extreme limits here. 1.64 here. So negative 1.6445, 1.645 here. So this accept region, this rejection region. So the answer, if we get in the shaded region, means we're rejecting hypothesis. So means there's a significant difference. Whenever we're rejecting, there's something happening. When we're not rejecting, there's no significant difference. Okay. So step one, state the hypothesis. Step two, state the decision rule. Step three, calculate the Z. So Z calculated is given by X bar minus mu over the standard error, which is given by standard deviation square root of n. So our mean we are trying to test is 110. Is it different from the original, which is 100? Okay, our standard deviation is what? Of square root of n, which is 36. 36 square root is 6. 6 into 12 is 2. 110 minus 100 is what? 10 over 2. We're going to get a 5. So where is the 5? 5 is somewhere here in the shaded region. What is our conclusion? Since our Z calculated, which is 5, is greater than 1.645, we are going to reject HO and conclude that there is a significant difference. Okay, reject HO and conclude that there is a statistical difference. So you need to identify important things here. Number one, you need to know whether there are two means that were given. The statistical mean and there is hypothetical mean. Statistical mean and hypothetical mean. Statistical mean is simply the mean that we calculate out of the numbers that we have. Okay, it's attached to a number.
Okay.
So
You're saying statistical mean
it's
is
attached to a number. Okay,
okay.
so for instance, you can say it is assumed that what? That babies weigh um 3.5 kgs. Okay, then you
Okay.
sampled 100 babies and you found that they weigh 4 kgs with standard deviation maybe 0.35 kgs at confidence level maybe
Excuse me, are you writing somewhere? The board
90%.
is
Okay.
the board is not. Don't know where you're writing that one. You're explaining. I can't see. It has
Okay.
not moved.
Let me be me.
Okay.
Okay. So I want us to learn how to um, identify information when we are given from a given sample space.
Okay.
So only looking at a two-tailed test in this regard to seeing how we're able to calculate the hypothesis. So there are four steps that um, involved when we are calculating the hypothesis. Number one, we need to state the hypothesis. Number two, we need to um, state the level of significance. Number three, we need to calculate our Z calculate.
That's
Okay, so
yes.
let me beam the questions, okay, for you so that you can see how this is done. All right, so question number one reads as follows. It is assumed that an average weight of a baby is 3.5. So this is your mu because it's not attached to a number. It's just an assumption. So mu.
Okay.
A sample of 64 babies is taken. So this is your n. So n produces what? Mean. And the mean weight was 3.8. So 3.8 is our x bar because it was actually calculated. The standard deviation is 0.40. So this is our standard deviation. Test at 5% level of significance whether the average weight is significantly different from 3.5. So step one, state the hypothesis, which is this one here. Our mean is 3.5. Maybe our mean is not equal to 3.5. Step two, state the level of significance. Our level of significance is what? 5%. So what is 5%? The Z for 5% is what?
Mm,
1.96, right?
1.96.
96. Then you can even show the shading here. So on the left side, you put 1.96. On the right side, you put 1.96. So if it is in the shaded region, we reject. If in the unshaded region, we fail to reject. Are we together?
Yes. Yes.
Then step three, we calculate the Z. So we know that Z is equal to x bar minus mu over
X
the
bar.
standard error. The standard error is the standard deviation of a square root of n. You can calculate them separately. So our x bar was what? 3.8 minus 3.5 over standard error, standard deviation over root of n. So here you find 6.0. So where is 6.0? Is it in the shaded region or the unshaded region? So you discover that it is in the shaded region here. Okay, so meaning what is
Yes.
our conclusion? Since it's greater than that, we reject H, or meaning there is strong evidence here to show that the mean is different, meaning the doctors are lying. All right. Are we
All
together?
right.
Is that
We are
clear?
together.
Yeah, so hypothesis testing is very important and very applicable because it helps us test differences. So if there's ever a time when hypothesis testing is important for statisticians, it's now, especially when there are price fluctuations. Okay, so let's look at another one.
Sure.
Um, These are claims. So question number 2, suppose a factory has a mean weight of packed sugar 1 kg. It's written 1 kg there, but after sampling 50 packets at Zambia Sugar, we found that the mean was 0.97 with standard deviation 0.05. So we want to see at 5%, is there a difference? Should we sue them? They are stealing from us, or is it insignificant? So we put mean is 1.0, mean is not equal to 1.0. The standard error is standard deviation over root n. So you find 0.007. So the z is simply x bar minus mu over standard error. So here we're finding what? Negative 4.24. So
24.
here our at 5%, what is our z? 1.96. So here we put negative 1.96 on
1.96.
the right side, left side, and here 1.96. So we discover that when we calculate that, negative 4 is somewhere here in the shaded region. So what does this mean? Means there's a statistical difference. 1 kg is not equal to 0.97. So the mean weight is statistically different. So we can sue them. They're stealing from us. You get it? So if it was inside
Okay.
here, we say we fail to reject HO. We can say accept HO. Would have said no, it's negligible. It's just machine error, but this error is too significant for people to protest. All right?
All
Are we
right.
together?
We are together.
Mhm. So I'm just doing the two-tailed test for now so to understand the next sessions we'll be having will be a double-tailed test so that you can also understand the differences. Okay, so we have question number 3. The lifespan of the what? Of a battery is not to be normally distributed with a claim of what? 500 hours. So this is mu, 500 hours. And sample of the 6 batteries and it's 36 have to be tested, and the lifespan was found to be 48. Standard deviation 40 hours, and then 5% level pencil test. So mu is what? Mu is what?
It's 500.
Yes. Okay. So mu is 500. Okay, then level of significance what? Z is 1.96, which is this part here. So here, calculate 1.96, 1.96. Then calculate our Z calculated. So Z calculated, it's 480 minus 500 over this. So we're going to find 3.0, which is in the shaded region. We also reject HO. Okay, so this is how it's supposed to be done. Are we together?
Yes, yes.
Okay. Hmm. It's easy to follow once you understand
Yeah,
the uh,
I'm getting the principles behind.
right. So um I'll give you homework just based on what we have done today. I think this
All
is,
right.
yeah. Thank you so much for your time.